Okay, good evening, ladies and gentlemen. We are reviewing some of the problems from 7.1 and 7.2 here. So 7.1 is ratios and proportions. 7.2 is similar polygons. Okay, so ratio. First and foremost, and you should have this in your notes from class, a ratio is nothing more than comparing two numbers by with division. Okay, so the number of girls and boys in your family. For my, I've got me and my son. I've got a wife and 3 daughters. So that ratio of boys to girls would be 2 to 3. So yeah, pretty straightforward. So what we have here with the ratios, when we look at problems number 9, 10, 11, 12, they say create a ratio of the first measurement to the second measurement. So I'm going to look at number 12. Number 12 has the court. Yes, that's a U, not a A. If it was an A, it would be cart or court. Anyway, to table. And again, 9 through 12, what we're using is the game of ping pong and the game of tennis, basically saying that one is a modified version of the other. So we have here that the ratio of court to table, court's the first one they give us, so that's going to go in the numerator position. So it's 26 yards to 9 feet. Now, even just giving those two numbers is itself a ratio, because a ratio is just comparing two measurements by division. That being said, what we really want to do is combine them and actually give it to the answer in a common unit. Here we're going to use either feet or yard. Now if we go 1 yard equals 3 feet, then we know that 9 feet, 9 divided by 3 is 3. So we get 3 yards. So there we have 26 yards to 3 yards. The yards disappear. So the ratio is 26 to 3. The court, for every 3 yards of table, you get 26 yards of court. So the court is 26 thirds larger than the table. And that's it. Also, we know we can't divide it anymore. We can't reduce it because 3 is a prime number. Now notice if we had gone the other way. If we had changed 26 yards into feet, we go 26 times 3. That would give us 78 over 9. And all we'd end up doing is then redividing by 3 and get back down to 26 over 3. So 26 over 3 is the correct answer. So looking at number 13. Now number 13, it says that the baseball team's winning ratio is 5 to 2. That means for every 5 games it wins, 2 games it loses. Or you could look at it and say for every 7 games it plays, it wins 5, loses 2. So that's wins to losses. That's the ratio there. Now we set that up. We're told that they play a total of 154 games per year. So what we do is we go 5x plus 2x equals 154. Because that x is going to be that scale factor, that coefficient that relates the two together. So we go 5x plus 2x equals 154. That gives us 7x equals 154. Or we divide by 7 and we get x equals 22. So what we now want to do is we want to go ahead and take that 22, plug it back into that x position. That gives us 5 times 22. That's the number of wins the team will have. We then go plus 2 plus 22. That's the number of losses. And that should add up to 154. So we end up with 110 plus 44 equals 154. 110 wins, 44 losses. Now notice, if I set that ratio up 5 to 2 equals 110 to 44, that ratio stays true. Watch, cross multiply. 2 times 110, 220 equals 5 times 44, 220. So we know that that's a true ratio, so they won 110 games, lost 44. Okay, we then have a triangle. This is kind of a similar problem. It's just with an extended ratio. Remember, an extended ratio is comparing 3 or more numbers. So we have a triangle that's in the sides are in the ratio of 6 to 7 to 9. And we know the perimeter is 88 centimeters. So we basically do the same thing. We go 6x plus 7x plus 9x equals 80 centimeters. So whatever x is, that's going to be our scale factor. That's going to be our coefficient of change, whatever you want to call it. So we add them up. 6 plus 7 is 13. 13 plus 9 is 22. So we have 22x equals 88 centimeters. Divide by 22, and we get x equals 4 centimeters. So now what we're going to do is we're going to multiply it by the 6, the 7, and the 9. 6 times 4, 24. 7 times 4, 28. 9 times 4, 36. Now we add all those up, bam, 88. Okay? So notice, this is, because if we set up this ratio, 24 to 28 to 36, we could reduce that, and we'd reduce it by a factor of 4. So the factor of 4 would bring us down to the base ratio of 6 to 7 to 9. Hopefully that made sense. Okay, moving on. 17. Again, with any of these, if it ever doesn't make sense, if you watch me go through it, go back, watch it again. If it still doesn't make sense, drop me an email and we'll try and figure out a different way to tell you how to do it. So we're looking at 17 now. Now 17 in the next couple of problems, it asks to solve the proportion. That just means solve for the variable in the proportion. Remember, a proportion is nothing more than two ratios set equal to each other. So 1/3 equals 3x in all of these. Cross multiply. Remember, we've got that cross product theorem. Let's use it. 3x equals 12. Divide both sides by 3. X equals 4. Okay, and that's solved. 19. We're going to flip where that x is. So now we have 4 over x equals 5/9. We're going to do the exact same thing. We're going to go 36, that's 9 times 4, equals 5x. Now, unlike number 17, this one's not going to turn out so pretty. We got 36 divided by 5, and we have x equals 7.2. You can also write that as 7 1/5, but 7.2 is probably easier. You can also leave it as 36/5. There's nothing wrong with that. 23. Now this one, instead of just a variable there, we have x plus 3. The fact that the problem itself is getting more complex in no way changes how we approach it. We're solving a proportion. We solve proportions by cross product. Cross multiplication, so we have 5 times 6 equals 3 times x plus 3. That gives us 30 times, and then we want to make sure we distribute that 3 to both the x and the 3. And we're going to get 3x plus 9. Skipping ahead, subtract 9, 27 divided by 3 gives us x equals 9. Okay? And if we go back and plug that in, that would make sense. That would give us 3/5 equals 6 over 12. And I made a mistake. It's 21. Sorry about the break there. 9 equals 7. And see, it's a good thing I go back and double check. Because what I did here is I looked at this and I got 36 equals 30. Clearly, that's wrong. So I want to go back, erase that, double check my work, and I see that what I did was right here. I went 30 minus 9 equals 27. 30 minus 9 doesn't equal 27. 30 minus 9 equals 21. 21 divided by 3 equals 7. So now I can go over here and I can go 3 over 5 equals 6 over 10. Now, cross products give me 30 equals 30. That's correct. So I'm good to go. So, moving on, let's look at number 40. So now I have 1 over 7y minus 5 equals 2 over 9y. So we're just upping the complexity a little bit. We're putting our variables on both sides, and that's fine. Cross product, same exact thing. Slightly more complex problem, same exact thing. If I go 2 plus 2, I know that's 4. But if I go 2 plus 28 plus 75 plus 36, I'm still just adding. This gets a little bit harder. So I have 2 times 7y minus 5 equals 9y times 1. That gives me, once I distribute, 14y minus 10 equals 9y. I'm going to subtract 14y from both sides. So I get negative 10 equals negative 5y. Divide by negative 5. And I get y equals 2. Now again, I can go back and I can plug this 2 up in here and make sure everything works out. That gives me 1 over 7 times 2 minus 5 equals 2 over 9 times 2. That's 1 over 14 minus 5 equals 2 over 18. That's 1 over 9 equals 2 over 18. Cross products, I get 18 equals 18. That is true, so I know I did it right. Onward and upward, we're going to jump forward to page 444. Now in this section, we're talking about 7.2 now, and we're talking about similar polygons. So the first set, they just give us the polygon names. They actually draw a picture. You know me and pictures don't mix, so I'm just going to give you the name. And it asks us to match up all of the congruent angles and then write the extended proportion for the sides. So congruent angles, we're going to start off. We're going to start off by doing all the angles. Now again, the order in which we put these is important. Now I color-coded, it's first to first, second to second, third to third, fourth to fourth. Each of those, if we had written that RSTV is similar to FEDG, that would mean that R and F are the same angle. So now that we've got the angles down, we got to go sides. Now remember, unlike where congruent, if these were congruent, we'd say that side RS is congruent to side DE. But we're not saying they're congruent, so they're not similar. Or they're not identical, they're similar, which means that proportionately they're the same. Which means we're going to take RS, right there, first side, and say that its ratio of the first side of RS to the first side of DE is going to be the same as the ratio of the second side to the second side, ST to EF. Which means, and that is to the third side, TV and FG. And then the fourth side, RV to DG. This right there, that's an extended proportion. That's how we know with any sort of similar polygon, we get to write that extended proportion. Number 12. So number 12 is going to give us two triangles, ABC, DEF, actually FED, doesn't matter, because they are both equilateral triangles. Now, if you remember what I said all equilateral triangles are similar, and here's why. If it's an equilateral triangle, equilateral means equiangular. Equiangular means that all of these are 60. See how all three are equal here, and they're equal to here. So it's 60 and 60. And then we can set up that extended ratio of side to side to side. 9 to 15, 9 to 15, 9 to 15. They're all equal. That's our extended ratio. The scale factor. Scale factor is the reduced ratio. So 9 to 15th reduces 3 to 5ths. So 3/5 going smaller, 5/3 going larger. And that gives us the similarity statement of ABC is similar to DEF. Okay, last one. See, short 15-minute video and you learn all you need to do. It's like taking a multivitamin in the morning, right? Quick, painless, it's over, and you got done what you need to get done. So on 18, we're going to start off by looking at the picture. Okay, so here we have two triangles. We have a big one that kind of, or a little one kind of locked inside a big one. Now we're being told from the directions on number 18 that these two triangles are proportionate. Okay, so they're similar triangles. So what I like to do is separate them out. Draw them out. So we have one triangle, y, x, 5, and a second triangle that's 6, 8, 10. Now we know that if we have two similar triangles, as we do here, that we get to write that extended proportion. Now we have two variables here. So what I'm going to do is I'm going to write the extended proportion with my completed ratio in the middle. So y over 6 equals 5 over 10 equals x over 8. And if we're feeling special, you see that 5 over 10 reduces to 1/2, and you can just quickly fill in y and x. I want to go about the legitimate way, do the full work that way. When it doesn't reduce so easily, you know what you're doing. And that again, whenever we're solving proportions, we want to cross multiply. So we cross multiply the y and the 10, the 5 and the 6. That gives us 30 equals 10y. Divide both sides by 10. And boom, you get y equals 3. You're then going to do the same thing on the other side. You're going to go 8 times 5 equals 10 times x. That gives you 10x equals 8 times 5. 8 times 5 is 40, so just drop that in there. So 10x equals 40. We then want to use our division property of equality, divide both sides by 10 without changing the equal sign. We get x equals 4. And that's our answer. If you have any questions, let me know. Other than that, have a wonderful evening. See you guys bright and early tomorrow.